Hello, hello. So yeah, basically there was some technical issue last time, and so I'm back again. Um, so what we were reading was the fact that during the case of if statements that we are using in the shader code, in case of constants, performance will not be affected. In case of uniform, performance should not be affected. But in case of dynamic if statements, so if the pixel is not within the cup, right? If the pixel for which we are is not within the cup, if the water droplet is present above, render current pixel with water above. If above is empty, current pixel is empty. If the pixel is not within the cup, if the water droplet is present above, render current pixel with water above. If above is empty, current pixel is empty. If the pixel is within the cup, right? So there are two cases: if the pixel is not within the cup, and if the pixel is within the cup. Acha. You can pass a 1D array. I think in the 1D array we'll have enough information to do all the computations. So yeah, it is possible. You can pass a 1D array to do all the calculations. Yeah. At every point with newness, there comes uh, some sort of things, right? I said, how will I do that? How will I do that? Yeah, so this is what how it is. We can maybe start with some other. We can take up some easier problem first, then move into this problem as well. That is also fine. Uh, that might seem a bit difficult, but that is still fine. We have 3 or 4 problems that we are currently facing, so I don't think it's an issue if we start with some other problem first as well. I definitely have to start doing a lot bigger streams, I think, because to do all the computations. So yeah, it is possible. You can pass a 1D array to do all the calculations. Yeah. At every point with newness, there comes uh, some sort of things, right? As in, how will I do that? How will I do that? Really, there was some technical issue last time, and yeah, I was not spacing out. I was just checking the things because apparently it shows in the OBS that things are frames are getting dropped, but so I thought the live would have been cancelled because usually that is what happens when frames start getting dropped. Usually the live ends. So, but apparently that has not happened, which is great. Uh, so how? What is the next step that should be done, right? Uh, this is where usually I get stuck. No, when one step, I I am part of me is always like taking things very slow, spacing out, and like I have to listen to music or see something so that I can I cannot do the cut variation of this, right? As in that is how you be urgent, right? But that is not something I'm very familiar with. I take my sweet time. But this is not the case here because we have to tackle a lot of obstacles. So yeah, um, we cannot be doing that much. Uh, yeah, why am why I have that GL text image 2D thing in my? It's fine. So maybe then let's work through the algorithm only first, right? We'll just work through the algorithm. I was planning to do something else first, as in do the animating part first, or do understand where is the box, or better understanding of the water droplets and all that, right? But now I think we'll start with the. But the important thing to note is that the water cup only constitute about like a um, small amount of pixels, right? As in, let's just look at the image, right? If where is that image? Yeah, in this, it would the water cup. Suppose if you have a box for this as well. Uh, this is one third of this also. So suppose you have a big box. This still should be only like some 1/10 or 1/15th of the computations where you have to do actual computations, right? So in that case only, there is a chance of having a lot of 1/15th for that. And for the water droplet will also be more or less very less part of the screen, right? If cup is 1/15th, the water droplet would be some maybe this is like 1/5 or 1/6 of the cup, 1/100th or something like that. So only those parts would be extremely slow, right? Even if you take a 800 into 600 kind of screen, only very small part of it. So 800 into 600 by 15 is something like, let's just calculate that. Yes, a small calculation, right? Only this much amount of and some I'm just taking an example. Only this much amount of computations would require divergence, right? Others would anyway, in some sense or the other, will be very fast because you would not be doing anything great in that. So yeah, I feel that even if we had all these complex calculations in this, it shouldn't, in some sense or the other, slow down the performance that much, especially if you are. So, what is the ratio that we are taking currently? What is the screen size that we are taking currently? It is there in texture helper, I guess. Yeah, height 324 into 576. This was also a bit slow, so should be 432 into 678. 432 into 678. That should be correct, I guess. 432 into 678 by 15. Yeah, so for around 20,000 cells, right? Only those cells will have like a lot of or a different set of computation, I would say, which would result in slowing down of stuff. So this should be fine, I guess. Yeah, so this is just me justifying the model in some sense of it. If the cup was big or if the cup took up a lot of the screen, then the case would have been different. But in this case, at least I would assume that it shouldn't be that bothersome. Give me 2 minutes, I'll be back. Yeah, so that is one of the things that needs to be done, which is go through the yeah, when starting a new session, right? New, or when I come from a break, I am kind of spaced out anyway, so this is quite understandable. But my point is, I have to complete the. Um, I'll go for the pixel first, and then we'll see what happens from there. So again, going back, so there were two conditions that were predominant. One, the pixel is not within the cup, and one, the pixel is within the cup. The cup is something that we have identified as a square. Uh, let's just say we will just give those coordinates directly to the shader. We for that will require some manual work, but that is for later. The water droplet is present above, render current pixel with water above. If above is empty, current pixel is empty. Great. If the pixel is within the cup, if all pixels above are empty, if the pixel is within the cup, if all pixels above are empty, if current pixel is empty, if current pixel has water. So these are many things that we would have to take into consideration. The within the cup with cup case, and within the cup, if all pixels above are empty, if current pixel is empty, current pixel is stays empty. If current pixel has water, if connected the connected down, what if the connected down water index has obstruction? If diagonal left and diagonal right below has water, if diagonal left and diagonal right below has water, then water will remain. Okay. If connected, I think we should code this up first, right? As in, there will be multiple cases. I think this has to be simplified as well. But we need to code this up, and we need to. The connected down data structure is something that is very difficult to. I think this is still not easily. We have to come ease with this concept, right? As in currently it is not that easily in my head, but after some point of time it will become easier for me to understand this. uh, but you yourself have to work in such a way that this becomes easier for you. uh, Current pixel has water if the connected down water index has obstruction. If diagonal left and diagonal right below has water, then water will remain. If connected down does not have obstruction, if water present directly above, then show water, else show empty space. I think this should cover all the conditions. Is there a condition in which this particular pixel is moving down and it is filled by uh, something from the left or the right side? I don't think such a condition is there. Or is it possible also? Yeah, see, so now this has become very complicated with this connected down structure, and the lingo itself has become complicated. Second, I am not able to show things via. I'm not able to show things via an image. So these things are there now. I think firstly we should implement what is there currently, right? And then maybe have a connected down structure which only. So suppose we don't take into consideration the left and right diagonal thing, right? Then this covers everything, right? If if all pixels are empty, if current pixel is empty, current pixel will stay empty. There wouldn't be a case in which there is a gap and one cell above is has water. That case wouldn't happen, right? If current pixel has water, current pixel has water. If above pixel has water, if current pixel is empty, current pixel will have a water. If the pixel is within the cup, if all pixels above are empty, if current pixel is empty, current pixel will stay empty. If above pixel has water, if current pixel is empty, current pixel will have water. If current pixel has water, if the connected down water has obstruction, yeah, so this is without the spreading of water taken into account, right? So let us walk through the algo again. If the pixel is not within the cup, if the water droplet is present above, render current pixel with water above. If above is empty, current pixel is empty. So this is for not within the cup. If the pixel is within the cup, if all pixels above are empty, if current pixel is empty, current pixel will stay empty. Great. ठीक है, I think this is the basic algorithm. And for the how will I update the connected down part? Um, the connected down part will be updated in such a way that above pixel has water. If current pixel is empty, current pixel will have water. Great. I spaced out. Sense of urgency is going. Yeah, this is bad. Um, yeah, we have made a rough algorithm, and we have to have an initial whenever a water droplet comes back and all this. I think with this we can do some initial work. For all pixels, we need to make sure we have the connected down wala, right? As in, what is this connected down water index saying? That for a pixel that does not contain water, connected down data structure explanation. If a pixel does not have water, the connected down data structure will show -1. Okay. If a pixel has water, the connected down data structure will show um, index y such that uh, for y1 such that for all pixels between current y coordinate and y1 coordinate with same x coordinate, the pixel has water. Right? Connected down data structure explanation. If a pixel does not have water, the connected down data structure will show -1. If a pixel has water, the connected down data structure will show index y1 such that all pixels between current y coordinate and y1 coordinate with same x coordinate, the pixel has water. Inclusive, it should be inclusive, right? This is just a standard that we'll be using. So if there is no water droplet below, just below, it will just say, yeah, the current coordinates, just the current coordinate. Yeah, okay. But now the important part is how to initialize this connected down data structure, right? So that is one of the important things that now will come to play. Maybe we can pre-process and keep it, right? As in, every time we already have the image, so we can do some offline computation now and then just use the same, right? We can somehow see. Yeah, we can somehow see how we can do this for each and every time we are uploading a particular each and every time we are uploading a particular um, cell, right? So yeah. I'll be back for this. I think I need a couple of minutes break. Yeah, so we have reached a point in which we have to do the bit of the empirical work, which can be considered as some sort of dirty work. But that is how you make the calculations faster. That's how you do your preloading faster and all that. Otherwise, it would be difficult, right? As in, yeah, it will be difficult. Uh, Store the output of a shader in a file. Is it possible? No, this is with buffers. This is the frame buffer object thing that we were talking about anyway. Yeah, so these things are there, I guess, as in we would have to do some sort of um, difficult tasks here. It's not going to be easy for sure. The pre-processing part of it is definitely not going to be easy. But this has to be done and this has to be enjoyed also. As in that is the you cannot be saying that this is kind of very difficult. But I think more breaks, as in more amount of breaks, and then we should be able to do this, I guess. Um, yeah, I guess we should be able to do it. It shouldn't be that big of a challenge. Um, Only thing is pre-processing part of it, right? As in, so we have to do some sort of pre-processing. I'll just I'll think I'll stop the stream now here. I know this is kind of a bummer, but I guess I'll stop the stream now here and then I'll get back to this particular. I mean, I'll get back with a. As in now, we have to do a lot of empirical work that I have to. I'll get back to my empirical mode on. Right? As in, so, and after I'm having that empirical mode on, we'll just try and solve this problem. So that should be fun. I mean, you cannot say it is not going to be fun. As in, we have to enjoy it anyway. So I guess I'll stop. I'll be back in 10-15 minutes, I guess. So yeah. And we will go through the empirical part of it. See you soon.